the main logic of this HDA is basically done, and we're not really going to edit it anymore. But I have a couple more options, extra options for this HDA. Something like remove failed cook directories and output and open the output directory and delete all file outputs from disk. So I want to set up logic for those. And let's start by the most involved one, which is removing of the failed cook directories, which is this one. So to show how it's going to work, I went ahead and made sure that I failed a couple of texture cooks out. So in this ROP fetch, I basically have failed to cook out normal maps in 2 texture sets. So for the setup, what I have, I basically went ahead and deleted. I am cooking these 5 texture sets, and I went ahead and deleted normal maps from 2 of these. So, and I have unchecked this only common types toggle. That means that I have option to select the normal map, and once we are sampling normal maps for those 2 texture sets that doesn't have normal map, it's going to show the errors. And I now that I have cooked it out, you can see that basically I have 5 texture sets, and 2 of them are without the normal maps. So I want to make sure that I am not keeping texture sets without the basically incomplete texture sets. So I want to basically go ahead and delete both of these directories. So first of all, I want to put down a filter by state. Inside here, I can basically only select the failed cook items. So if you select this failed and unselect succeeded, and let's try to cook out. You'll see that you're going to get this purple kind of a node icon. So this means that this means that this is always going to recook the. So this basically means that this is a dynamic. We cannot really put down as we cannot really generate this node because this is dynamic node. It basically always has to know which items have failed, so it's going to try to recook the 2 failed items upstream. So this filtering takes a little bit of time because this node upstream has to try to recook the failed items. So this is one thing to note about these dynamic nodes, and that basically means that everything after that is going to be a dynamic node setup, node graph, and so we have to work with it a little bit differently. So basically we have gotten our 2 failed items, and make sure that you also clear the failure state on them. Now that we have our 2 items, I want to make sure that I always pass at least one work item. So because if we have no failed work items, basically this node is going to be empty. There won't be any work items, and nothing will be booked after this work item because these networks work on the cook item, basically for each cook item. So what you can do is put down a generic generator and just go ahead and create a generic work item with no attributes. And then you just put down a merge. We are basically just merging these together. So this will make sure that we have always, basically that means that if we have one work item, that means there are no failed work items. And for the logic of the code, I want to put down a Python partitioner. So the partitioner actually I had the most luck working with because of the way that I want to implement the debugging and console. Basically, I want to print out some information to console to signify to the user what is going on in this network when we are actually trying to delete these failed items, because this is not going to be instantaneous because of this is a dynamic node. So inside here, let me go ahead and open this let's open this up in the editor. So I want to go ahead and and check if the so we have, this is a little bit different, so this is not a, so I have used the we use the Python script and Python, which one we also use? We also use the Python processor node. So this is a Python partition node. So this is going to create a new partitions. Basically, the same thing that we can put down like a partition by attribute is going to basically combine multiple work items. This node basically does this only with the custom logic in it. But we also, but for this to work, we do need at least one work item. So this is why we pass this generic work item always. So inside here, I want to basically check the length of the work items. So if the length of the work items equals 1, that means we have no failed work items, and we basically just print out no failed work items found, and that's it. We're not going to do anything further. But if we have more than 1, that means we want to pass every work item from this node along the further down the network. So we have to create a new partition, because this node creates partitions. We can't just pass down the work items. So inside here, else for work item in work items, we go ahead, if the work item has attribute common name, we go taking this partition holder and add item to the partition and work items, and 0 is like basically the index of the work item of the partition. And since I want to every work item inside the same partition, I always pass 0. And the check for the attribute is to make sure that I do not pass this generic work item, because we don't really need it. This is just for the debug purpose. And since it doesn't have a, this is going to check if it has a common name attribute, and if it doesn't, it's not going to add it. And let's actually go ahead and cook it. And you'll see all these purple icons. That means this is dynamic, and it's not going to instantaneously cook every time like something like from these networks did, where we could see easily a preview of the cook. And you can see that we have basically partitions items. We have merged these two partitions together. And I want to make sure that I want to expand this partition. Partition expand. And only thing I want to make sure here is upstream items in upstream partition. And if you cook it, you're going to basically get the back to this state where we have two items. Now I want to go ahead and create the attribute that's going to signify the folder that I want to delete. So attribute create. And here I want to create a string attribute. I call it delete folder directory. The delete directory is going to be the value of for each one of these, the destination root directory plus the destination directory name. And to bring it a little bit faster, I'm just going to copy this expression right here. So destination root directory backticks / like that. Now we have our deletion, and since the multiple textures can fail to cook inside in the same texture set, I want to make sure that I now go ahead and partition by attribute. And I want to basically partition by the newly created delete directory. So our delete by is set up. So distinct attribute values, all of these defaults should work just fine. And now I could go ahead and put down a remove file node. And in this remove file, I want to point to my delete directory attribute. A custom file path p at delete directory. And make sure to check if it works. Put down only dry run so that it actually doesn't delete the files just yet for the debugging. We don't want to recook the network to get the textures missing. So make sure that you go ahead and put down to the dry run, and let's try to cook it out. So we should get these two work items that's going to be deleted. And if you take a look at these attributes, these should basically be paths to these two directories that doesn't have a full texture set inside them. And basically we want to go ahead and put down a null node and call the remove fails it. So this is going to be the node that we want to call to cook from the Python script. And remember that I set my constant values in my Python script, in my Python module, and which is called the node remove fails, and its name has to be remove fails, which is basically this one, this node, because we want to go ahead and call from our Python module to cook it. And now we have basically set this everything subsets here, and now we want to go ahead and create the logic for the create logic for the callback script to remove these files. So this is going to actually introduce a new method inside Python module. So let's go ahead and do that. Inside our Python module, what I want to do is go ahead and create the new function. Let's call this remove files. So I'm going to handle with this function two cases. So for in my HDA, I can delete. I have two options for deletion of files, which is delete all the files all outputs from disk. So basically all the directories that I created, without checking if any of them failed. Basically any cook, delete all of the cook directories. And I also have ability to remove failed cook directories. So these two options are going to basically handled by the same function. In this function, the node parameter is going to be referenced to the node that I want to cook to delete these files. So in my case, the remove files basically parameter is going to reference the object of a node remove fails. So in here I want to make sure that I show two different messages based on which node I want to cook. So I'm going to have this remove fails, and I have another subnetwork that's going to delete all of the files. So all of the files. So I have two different nodes, and I want to make sure that the message can be different for both of them. So this is where I put down if the node name equals basically the constant value that I put inside here, remove output or remove fails. The message is going to be delete output files on disk or delete failed cook item directories. Inside here I want to go ahead and create the message. I check if we have a message, and then I want to remove data. And this is a who.ui display message. So it's going to pop up the message with OK and cancel buttons. And based on the OK or cancel pressed, which button is pressed, we want to proceed or do not proceed. So we put down our message as a text that's going to be shown. The severity, put down as a warning. Default choice is going to be 1, so that's going to be cancel. I think this default choice is basically selected when you press the basically X button on the window. And then the title is going to be the same for both options, delete files on disk. And then we want to go ahead and check if we have if the remove data equals 0. So the 0 is going to be the button option of 0, so basically OK. So that means we want to go ahead and proceed with the deletion of files. And then I can basically press the node.cook work items. But before I actually cook them, I want to go ahead and display the console message that I'm checking for failed cook items if I am removing the failed cook directories inside here. You can see I'm checking if the node name is equal to the node remove fails string, and that's going to be immediately shown. Since we know that this network is going to take a couple of seconds to cook, I want to make sure that the user sees already a message that it actually goes so that something is happening inside the subnetwork, and it actually checks for the fails. That's pretty much it. This cook work items is the only thing that we need for us to cook this node, and that's basically it. Now that we have our function, let's go ahead and connect it to the remove button. So remove failed cook directories. In this callback script, I want to call this function. So it's pretty simple. We have to call get our Python module who.phm dot remove files, and then I want to reference to the remove files top node. So we can use basically a Quark's directory. Quark directory that is always available in these parameters. I want to get our node. So it's going to get the reference to the HDA node, and then I want to go ahead and call the node on that one. And the node we want to traverse our HDA node structure to that node, which is basically going to go to this topnet one. Topnet 1 / remove fails. And this is going to return the node object of remove fails node. And just go ahead and make sure that there's 2 brackets at the end. And this should basically pass the correct parameter to our remove files directory. Applied. And let's try it out. So first of all, let's keep our dry run connected, and let's try to remove failed cook directories. You can see we have our message, so that's good. Okay. You can see it's going to basically create this message, and it's basically done checking the cooks. So I probably want to also make sure that there's also so I want to maybe the no cook items would be shown if we have no failed cook items. So also want to debug what we have deleted. Right, I also forgot about this one. So it seems like this is working, but I want to make sure that I also log out what I have deleted. So we can put down another Python partitioner. Inside here, let me open this up. And in this Python partitioner, let's go ahead and I have this code set up. So this is going to basically be triggered only if we have at least one work item, because we are not doing anything after if this has no work item, because we are not passing it after this partition node anything if there's no failed work items. And this code is pretty simple. We're basically we are printing out deleted failed work for work item folders, and then we basically just go ahead and for each work item we get our string attribute of delete directory and print it out, deleted directory. And after that, once we complete our loop, we just write out completed. Let's actually check it out now. So let me go ahead and do it again. Remove failed cook items. So we have our message. That's nice. And you'll see that we have now got our message that it's completed. It has shown that it has deleted these 2. And obviously it has not, because we are actually dry running it. Let's actually go ahead and cook it without dry run. So inside here, uncheck dry run. Let's clear the message. And let me remove failed. Okay, let's take a look at this directory. You can see these 2 directories has gone. Now we have left only the 3 texture set that has complete texture set. And it has shown what was deleted, and also shown that it has successfully completed, so we know that we can continue to work with this network. So this is basically it. And one thing to note is if you go ahead and recook this node, if you press on this remove failed cook directories again, the ROP fetch node above here is actually going to start to recreate these two failed directories that were deleted. Because ROP fetch knows that these directories no longer exist, so it basically recreates the failed directory, failed texture set directories, and it's going to basically create it and delete it immediately. So make sure that you do not run this when you know that you have already deleted all the fails, because you do not want to create a new failed texture sets and then immediately delete them. You can actually go ahead and let me cook it again. You can actually see in directory how it's going to create these two texture sets and then delete them immediately. You can see it has two texture sets. It's got them, and then these cooked out and immediately deleted them. And now I want to implement the deletion of all the output files from the disk. And this is going to be a lot simpler. So basically we do not want to check for any unsuccessfully created textures, since we are deleting the texture directories. So instead of fetching the directories from ROP fetch, I can basically take it from here. So this is going to instantaneously delete these files. So put down attribute, so it's going to add partition by attribute, and just connect where we created our folder names. Just go ahead and connect it inside here, maybe somewhere inside here. Inside here I want to partition by the destination directory name. Cook it, you can see 5 directories. We have 5 directories since we have 5 texture sets, and go ahead and create a file remove inside here. And the file remove is going to be basically the same thing that we set up our attribute inside here. Attribute create delete directory. I'm just going to copy this inside here, and the path is going to be this one: destination root directory / destination directory name. And let's put it on a dry run. Let's cook it so this doesn't show any errors. Let's turn off the dry run. Clear it, cook it. You can see now it's gone. So we have deleted all the directories from here too. And let's hook this up to the callback of the button. So let's take a look at our script, what we call this remove output node. So I want to make sure that I call this remove output node, and I want to call this node. So what I want to do is so inside parameters, let's find the delete all file outputs from disk. Let's go ahead and actually copy the remove failed outputs code inside delete all file outputs inside callback. Only thing that we have to change is this, instead of calling on the remove fails, we want to call the remove output. So this should basically this should be done. So I went ahead and recook the textures. Let me go ahead and try to call this from this button. Right here. Delete all outputs from disk. So this should basically go ahead and delete them all. So you can see it didn't delete it. And to fix this cache state, you can just press dirty all. So you can see it went ahead and deleted remove the cooked state from all of these. And you go ahead and delete all outputs from disk. Press it again. You can see it has recooked it and done it inside here. So this is one thing that you can do to make sure that these buttons work. Just press dirty all. It's going to clear all the cache states of the entire network. So this is basically we have implemented both of these delete files and remove file cook buttons. And one last thing that we have to do for the functionality standpoint is enabling this open output directory button. That is going to be another simple function inside Python module, and I'm going to leave it to the next video. We're going to do it in the next video. And in the next video, we're also going to talk about the help page and a couple of things to make it less painful to set up the help page. So see you in the next video.